Welcome to the second part of today's lecture on mole to gram to mole stoichiometry. So I'm going back to the equation that I had before. So here I was trying to figure out if I started with moles of hydrogen, 5 moles of hydrogen, how many grams of ammonia would I get? And this is the way we set up the problem. We started off with our given 5 moles of hydrogen. We multiplied it by the mole ratio. Again, it's a coefficient that goes in front of the unknown, divided by the coefficient that goes in front of the given. And again, moles of hydrogen are going to cancel out here. And then we multiply it by the molar mass of the unknown. So here the unknown was ammonia, and it's 17 grams per mole. If you don't remember how to do molar mass, I can put up a video on that too, or you can just take a look at your textbook. It's pretty straightforward. You're just adding the formula mass here is going to be 1 nitrogen and 3 hydrogens. Just look for the masses of these on your periodic table. You should get 17 grams. Again, moles of ammonia are going to cancel out diagonally, and you're going to be left with the thing you're looking for on top, grams of ammonia. Now, one thing I want to make sure everybody remembers is that when you're using the molar mass in a stoichiometry problem, the thing that goes with it in the fraction is always 1 mole of that substance. Always, always, always. So there should never be anything other than 1 mole with the molar mass. The only time you see something that's not 1 in front of the word mole is going to be sometimes in your mole ratio, and again, that's going to depend on your coefficients. Now, let's take a look back at the equation I was using, because we can actually do this whole thing in reverse. We can go from grams to moles instead. So if I have 25 grams of hydrogen and excess nitrogen, remember when I say excess, that means you don't have to worry about it. So we can just say we don't have to worry about the nitrogen. How many moles of ammonia can I make? So we're going to start this off the same way. This is what I have given, 25 grams of hydrogen, 25 grams of H2. That's my given. So we always start with our given. And then I'm going to multiply it by something that's eventually going to allow me to get to moles of ammonia. Now, I can't do that yet because there's really no equivalent between grams of hydrogen and moles of ammonia. There's no way to go directly from one to the other. But remember that in all stoichiometry problems, we have to eventually get to the mole ratio, but the only way to do that is to make sure that we've changed grams of hydrogen into moles of hydrogen first. And hopefully you remember from the previous video that to go from grams of something to moles of the same thing, you need the molar mass. Now, in this problem, now I need to have the 1 mole on top, because I'm going from grams to moles. I want to end up with moles on top, and I want to be able to cancel out grams diagonally. The molar mass of hydrogen is 2.02 grams per mole, right? There's 2 hydrogen atoms in it, so each hydrogen is 1.01 grams, so 2 of them is going to be 2.02. So notice that grams of hydrogen will cancel out like that. And then my next step, so every stoichiometry problem has to have the mole ratio. The next step is going to be my mole ratio. Remember, the mole ratio is going to be the coefficient in front of the unknown, and that's 2, divided by the coefficient in front of the given, and that's 3. And then notice that moles of hydrogen are going to cancel out, and the thing that I'm looking for is on the top. And then, as we've done before, we can multiply the top across, so 25 times 1 times 2, 25 times 1 times 2, divided by, and again, I want to put this all in parentheses, 2.02 times 3. And when I do that, I should get 8.3 moles of ammonia, which is what I'm looking for. And you can stop there because it's moles of ammonia. That's what you were looking for. So if you want to go from grams of given to moles of unknown, first you have to start with your balanced equation, but once you have that, you're just going to set it up like this: grams given times the molar mass of the given. But again, remember, if you look at it, it's going to be reversed. You're going to have the grams on the bottom now and 1 mole on the top. That's still the molar mass, it's just flipped. And then times the mole ratio. And that's how you do a gram